We've done this reaction once before to produce propiothanone, but we're going to perform it again and experiment a little bit. When heated together strongly, calcium salts of different carboxylic acids can react, giving off carbon dioxide and forming the corresponding mixed ketone. If one of the calcium salts used is calcium benzoate, then this potentially gives us the ability to produce some interesting ketones such as propiothanone and acetophenone using the calcium salts of propionic and acetic acid. So let's have a go and try this out. Okay, here's 50 grams of benzoic acid which we prepared from sodium benzoate food preservative, acidifying it with hydrochloric acid and then recrystallizing it from boiling water. It's a white crystalline solid as you can see here. We're going to try to do our reaction in a slightly ghetto style, and we're going to use calcium hydroxide to convert the acids into their calcium salts in the same flask that we react them. So here's a 15.2 gram portion of calcium hydroxide, which is enough to convert all the benzoic acid into calcium benzoate. Water will also be generated as a side product of the neutralization reaction, but we'll hopefully be able to distill this off first. Now for our second carboxylic acid. We're going to do something a bit different and use formic acid. We've got 19 ml of 88% formic acid solution here. This is an equal molar amount to the benzoic acid. And to convert this to the calcium salt, we've weighed out another portion of 15.3 grams of calcium hydroxide. Here's our reactants. The two carboxylic acids in equal molar amounts, and the corresponding portions of calcium hydroxide to convert them to the calcium salts. We're going to use a 500 ml flask to perform the reaction. We just hope that it won't get killed in the process. First we'll get the benzoic acid in. It was a bit painful, but we got it all in. And now the formic acid. Now we're going to slowly stir in the proportions of calcium hydroxide to neutralize the acids and form the calcium salts. We stir the solids together in the flask and keep adding the calcium hydroxide. As you can see, quite a bit of heat is generated and water starts to condense inside the flask. Here we are with all the calcium hydroxide added and the mixture well stirred. We give the flask a good shake for a few minutes to make sure that the solids are mixed. Okay, here we go. As we heat, any residual formic acid will vaporize and this should complete any neutralization reaction. We make sure that the ground glass joint of the flask is really clean so that the chances of it freezing up are reduced. We'll also use lots of grease on the adapter we use. So let's set up for distillation. We're using the heating mantle so we can heat the flask very strongly. But first we're going to heat at medium strength so as to allow the neutralization to complete and in order to drive off the water that has been formed. We don't bother with a thermometer as it's not going to tell us anything useful. So we start heating on medium heat. Pretty soon we get water condensing and then distilling off. Once we've got about 15 ml of water, we start heating the flask more strongly to see if we can get a reaction to take place. After about 20 minutes we notice a white deposit starting to form and build up in the condenser. This looks like benzoic acid. If our reaction works, then our ketone produced is going to actually be an aldehyde, benzaldehyde. As you can see from this reaction schema, we continue heating the mixture very strongly, and we can see puffs of white smoke appearing in the flask. Our distillate up until this point is completely aqueous with no separate organic layer. and with a few specks of what looks like benzoic acid floating around. We keep persevering and heating the mixture. But all we're getting is an increased buildup of solid inside the condenser. We've seen this before. This looks exactly the same as what happens when you attempt to distill benzaldehyde at standard atmospheric pressure. The compound oxidizes in air to benzoic acid. And we're pretty sure that's what is happening here. The distillate has a faint aroma of benzaldehyde, but it's like a burnt version. So our first experiment is a failure. Unless you've got an inert atmosphere, you can't make benzaldehyde via this process because the heat required simply decomposes it. So we allowed the reaction mixture to cool down, and luckily our flask was still intact and not too hard to clean. So let's try again. Okay, take two. Here's another 50 grams of benzoic acid, prepared exactly as before. Here's 15.2 grams of calcium hydroxide to convert this to the calcium salt. And now for our other carboxylic acid. This time we're going to use acetic acid. So here's 23 ml, which is an equal molar amount to the benzoic acid. And here's 15 grams of calcium hydroxide again, which will neutralize this and create calcium acetate. As before, here's all our starting materials. We're going to do exactly what we did before, mixing the acids in the 500 ml flask, and then stirring in the calcium hydroxide to neutralize. That's both our acids in. Now for the calcium hydroxide. The mixture becomes quite hot like before, but seems a little bit drier. There's a little bit of steam coming off. As before, we shook the flask to ensure a good mixing, and then set up for distillation. Medium heat to begin with in order to drive off the water. Soon we've got condensation, and then water starts to come off the mixture. We keep heating for about 30 minutes, and after this point we've got about 15 ml of water distilled off. So as before, at this point we increase the heat and start to blast the calcium salts in the flask. We've got more water condensing, so it's possible our benzoic acid has a bit of water in it. But soon we've got what appears to be a pale yellow-colored bubble of immiscible liquid forming. We inflate the flask so we can get the temperature as high as we can. And soon the bubble begins to grow into a separate layer of product in the receiving flask. As you can see here, this time in our reaction the product isn't an aldehyde because in acetic acid we've got an extra methyl group compared to formic acid. So the product is a ketone with a benzene ring on one side and a methyl on the other. This is acetophenone. And you can tell it's being produced because it has a quite intense sweet, sickly, flowery, perfumey aroma. And a different aroma to propiophenone, which is less sweet and slightly more rubbery and quite spicy. The distillation is quite slow and steady, and it takes a couple of hours before it dies down. The color of the solids in the boiling flask changes to yellow and then to a dark color. After about an hour and a half the distillation starts to slow down, and after 2 hours there's no more distillate coming off. So at this point we stopped heating and allowed the apparatus to cool down. Here's our receiving flask. We can't help but think that there might be a lot more product potentially in the boiling flask, but it seems very difficult to get a strong enough heat on the entire contents. We might see if this reaction is more efficient on a smaller scale. Here's our crude distillate with a top yellow colored organic layer containing our acetophenone. But it also contains a lot of other things as well, so we're going to need to separate them. First of all, we separate the organic layer into a different flask, and we do this using the pipette as there's not much of it and this is pretty easy. Okay, here's our organic layer. Now to separate the different components of this we're going to set up for distillation. We're going to use an oil bath to provide constant stable heat. And we should be able to tell what the different fractions coming off are if we record their boiling points. So let's get the heat up and see what comes off. We first get some boiling in the flask quite soon after switching on the heat. And a colorless liquid comes off and condenses at about 60 degrees C. When we showed you the original reaction schematic, you might have asked, I can't see that the calcium salts can react with each other, but what's stopping them from reacting with themselves in the same way? Well, the answer is nothing. So what has actually happened in our case here is 3 possible reactions of the 2 calcium salts with each other as you can see here. And with these reactions you always get a mixture of 3 products. In this case the possible products are not just acetophenone, but acetone and also benzophenone as well. And it just so happens that acetone boils at just under 60 degrees C. So there's the evidence for our first product. We collected around 10 mils of this and then the distillation stopped. So we turned up the heating on the hot plate and the oil bath. The joys of using baby oil in an oil bath. Once the temperature got to above 200 degrees we saw some more boiling in the flask. We covered the still head with foil to insulate it and help distillation. The vapor temperature rose quickly to about 200 degrees C. Once distillation of this fraction had completed we were left with an orange liquid which wouldn't boil off. So we allowed the apparatus to cool. Here's our 3 products. First up we collected about 10 mils of acetone, the product of calcium acetate reacting with itself. And next we've got about 6 grams of acetophenone boiling at about 200 degrees C. If you calculate that yield based on starting benzoic acid then it comes out at just over 12%. Not great, but we'll give you tips later on how to improve this. And finally, the residue in the boiling flask is impure benzophenone, created by the reaction of calcium benzoate with itself. It boils at nearly 300 degrees so a normal pressure distillation isn't possible for us with our setup. We did this reaction previously in a different video using calcium propionate and calcium benzoate to make propiophenone, and got much better results. So here's our tips on doing this well. Prepare the reagents dry and mix them as fine powders first. Then use a lot of heat. It's still not an efficient method, but it's an option for preparing these compounds if you don't have access to the reagents needed for Friedel-Crafts type reactions, which is the normal route. Thanks for watching and please consider supporting us using Patreon. The link is on the screen. Stay tuned.